So this talk is about deploying PHP applications on serverless providers. I guess this is pretty obvious. My name is Matthieu Napoli. I'm French. I come from Lyon. And I'm a software developer and software consultant. So I've been working with PHP for something like 10 years. And I've been working with it professionally. I've been working on open source projects too, on PHP standards as well. It will come in handy during the talk, you'll see. And yeah, that's about it. So yes, I work with PHP. So I want to address that first. I know maybe some of you think PHP is weird. That's something we often hear. That's fine. It's true, actually. But I love PHP. And I can tell you one thing that makes PHP really great. And I will tell you what it is, but in just a minute. This talk is about PHP, but it's about serverless too. So if you don't use PHP, I think you can still learn something from it. The idea is that we start with serverless in general. What is it? Then we will move towards code with function as a service, and then finally to PHP. So what is serverless? Where do we start? So the way I like to see this and explain it is to have a look at how we run applications today without serverless. Today, if we want to deploy and run an application in production, we think with resources. We will take a server, we will take a disk storage, and we will use those resources to install our application and run it. So moving to serverless is moving from thinking with those resources to thinking with thinking with services. With a service, you don't pay for a specific resource and install your application and stuff. You just pay for the service and the job gets done. So what do I mean by services? Let's take a few examples to be more specific. Storage as a service, I think it's a pretty great example, like Amazon S3. With S3, you don't have to pay for 200 gigabytes in a specific cloud provider. You just use S3 and you push your files, and that's it. You have database as a service, caching as a service, authentication as a service, search as a service. You have so many services today, it's like the era of services. And there's a reason why we are tending to move to those services. There are actually three main advantages. The first one is the operational effort. It's easier to use a service because it's higher level, obviously. Again, Amazon S3, perfect example. We don't have to think about renting. Do I need 200 gigabytes or 1 terabyte? I don't care. With Amazon, I just take S3 and just send my files. I don't have to think about monitoring the disk to make sure when it gets full that I can add a second one, etc. The second advantage is scalability. Again, Amazon S3, perfect example. I don't have a limit. I just send as many files as I want. And if I start to hit some limits, I guess I either do something really bad or something really good. And yeah, all this runs on the fact that Amazon or Microsoft or Google, they are probably better than me and maybe us to run those services, so we can rely on them. And finally, the costs. So this is something we often hear with serverless. The idea here is that since it's a service, we will pay for what we actually use. And this is a very important difference. We don't pay for a server, and then it just sits there, and we have to use it. We only pay for what we actually use, just like with Amazon S3 again. So this is serverless in general, but there's one particular service which is really interesting for developers. It's function as a service. So this one we could call it also execution as a service. It's basically the service of running an application in production. And what does it mean, running an application? Let's take a web application. What does it really mean? I like to think about it that way. We have an HTTP request, which is the green arrow. And when the HTTP request comes in, we have to execute some code. That's like the most basic thing we want to do with a web application. But in reality, that's not really how it works. It's more like this. See the large blue bar here? It's the web server. It's the daemon. It's running continuously and it's waiting for requests. And when a request comes in, the web server will actually execute the function we want to execute. So moving from the traditional approach to serverless, and function as a service more specifically, is about moving from this architecture to this. We take away from our applications the server, the daemon, anything that waits or that pulls a resource. And that's why it's called function as a service. We only write the actual function that is executed when there's the request. So there are two important things with function as a service we need to understand that are really different. The first one is that it's based on events. As I said, there is no waiting, there is no polling, there is no web server, there are no daemons. You write code that responds to events. It could be an HTTP request, like I said, but it can be so many things. It can be a cron, like every day at midnight, you will trigger this piece of code. It can be a message in a message queue. It can be, hey, there's a new file on Amazon S3, execute this piece of code. In any case, events. We write code that responds to events. And the second thing that's really important here is that the execution of the code is stateless. And what I mean by that, I will go back to here. What actually happens here when there's a request or an event, our code will be run inside a Linux container. So this is not Docker. This is a Linux container, but in any case, what happens here is that when there's the event, a new container will be booted with our code inside of it, and our code will be executed, handle the request, return response, whatever we want, and then everything will shut down. And on the next execution, everything will start again. So there is no shared memory, there is no shared state between the executions. Now, I'm simplifying a bit. In reality, there are some optimizations, like the instance of the container can be kept warm, like running, so that on the next execution, we don't have to start the container again, etc. But those are like technical details. What's really important here to understand is that it's stateless. And that will come important later. So this can be a huge change in architecture in Go applications, Python, Java, Node. This is a huge change because usually in those applications, the first thing the application do when it starts is it will stop and listen on the port 80 and wait for requests. So we have to remove that from our applications. And that can be a big change. But remember I said I love PHP. I love PHP. And yeah, this is not mine. I've been given it. That's really great. Fits the talk. I'm really happy about that. So I love PHP because of many things, but of one specific thing particularly. The fact that its execution model is stateless. It's one HTTP request in one PHP process. You have one PHP process and it will handle exactly and only one HTTP request. So it's exactly like what you can find in function as a service. One lambda, one function, one instance of a container will handle at a specific time only one HTTP request. And that's what makes PHP so simple. There is no concurrency issue. There is no multi-threading stuff. It's really simple. It's easy to run. It's easy to scale too. And yeah, it's as simple as it gets, basically. So back to functions as a service in general. Let's go back to the 3 advantages I mentioned and see how it fits with functions as a service. So I mentioned that it's easier to run. It's like a lower operational effort. Now, you have to be careful with that because that's true, but at the same time, we are changing everything. Like we are used to our Linux and MySQL and such stacks moving to serverless. So you have less things to worry about, but you have new things to worry about, new things to learn, new things to manage, even though you have less of that. Those are new. So that sometimes it can be a challenge. But in any case, you have much less things to worry about. You don't have to deal with Linux. You don't have to deal with the web server, how to configure it, how to optimize everything so that it can scale well, etc. It's really easy. And I want to show you how to just create a function, like a Lambda on Amazon. This is what you get when you log into Amazon and you want to create a Lambda. I will use the term Lambda and function. It's the same thing. So what you have to do is you have to add a zip file. This is your code. So why a zip file? That doesn't matter. You have many tools to deploy. You choose your runtime. So this is the language, like Node.js. You can use Go, Python, Java, C#, no, PowerShell. You have many choices. There is no PHP in there. That's OK. And finally, you define the handler. So it's actually really simple here. It's the file name dot the function name. So here we have a handler.js file and handle function. So you can see it's not that hard, and the code is also really simple. It's a function. So you have Python example, JavaScript example. Basically, it's a function that takes, and this is the most important thing here, the event variable. So this is an array or an object that that contains the data of the event that triggered the Lambda. So it can be the HTTP request. It can be the message of the message queue. It can be, I don't know if it's a cron. Maybe there's something in there. I don't really know. I haven't tried. And you can return a response. You don't have to, for example, for a cron. I don't think it makes sense to return a response. But for HTTP, it makes sense. For JavaScript, you can use a callback, but you can now use async await syntax. Anyway, as you can see, it's pretty simple. Just to get started, write a Lambda and push it into production. It's really easy. Then Amazon or Microsoft or Google, they will run your code. So the second advantage is I mentioned scalability. Why is it easy to scale? Let's go back here. This is what happens, with the container and stuff when you have one HTTP request or one event. When you have 0 events, there is nothing running, nothing. So you don't pay for a thing. What happens if there are 1,000 HTTP requests at the same time, the same millisecond? This is what happens. You have 1,000 containers that will be booted at the same time. Each container will contain one copy of your code and will handle just one request. That's it. And that's the stateless thing I was talking about. That's really important because that means that this Lambda and this Lambda, they don't have anything to do with each other. You can run them in separate data center. It's fine. It's really easy to scale because you're only limited by the number of servers you have available. And this is Amazon. They have so many servers. That's fine. So they deal with the servers. They deal with the resources. We just deal with writing the code. Now, this is not magic, though. If you have all those 1,000 containers and executions running a MySQL query, which goes in the same database, then you can have a bottleneck. That's just basic. But what you want to do, usually if you write serverless applications and if you expect traffic spikes like this, if you don't, then you're fine. But if you do, what you want to try to do is to write serverless applications from end to end. So you may want to use, for example, things that can scale really easily. You now have Amazon RDS Aura serverless. So those are RDS instances that can scale really quickly. You have MongoDB maybe to look into. But that's something to keep in mind. And finally, we have the costs. Why can this be cheaper? So again, with the web thing, this is an example of a web application. This is one day, and this is a traffic in production. So you can see that during the night, there is not so much traffic. At 8 a.m., you have a bit of a traffic spike. Then it calms down. And at 9 p.m., that's where you have the most people on the website. So if you don't do serverless, if you have a server, what you want to do, obviously, is to have a server that can handle that traffic spike. So you will buy and pay for a server that basically represents the blue box here, something that at 9 p.m. is perfect. It can handle the traffic spike, maybe twice the traffic spike, but at any other moment in the day, it's too powerful. It's like it's sitting idle here. With the serverless approach, you actually pay the execution of the functions of your code by the hundred of milliseconds. So if your Lambda, like for one HTTP request, takes 300 milliseconds to execute, you will pay for 300 milliseconds of execution time. So you pay exactly for what you use. So here, you would pay something that is kind of proportional to the green area here, right? So if we take this, this is a bit theoretical, I know, but if we take this further, if you use serverless, you would pay something proportional to the green area. If you don't use serverless, you will pay something proportional to the green plus the blue area, like the whole box. So where I'm going with this is that in your application graph, the more blue you have here, the more resources you are wasting. The more money you are paying for resources you don't actually use. So the more blue you have, the more you could save by moving to serverless. So for some applications, you wouldn't save really that much money. For some other applications, like here we have a lot of blue, that could be interesting. For some other applications like this, that's really, really interesting. Like the batch processes that run during the night, or the crons, or those workers, those, again, batch processes. That could be really interesting. Again, it depends on your application. So function as a service is available as Amazon Lambda, AWS Lambda, sorry, on Amazon Web Services. You have IBM OpenWhisk, which actually run Docker containers here. So that's interesting. You can run PHP here. You can run anything you want with Docker. There is no support for PHP on Amazon Lambda. You have Microsoft Azure Functions, which has experimental support for PHP, which I couldn't make it work last time I tried, but I guess they still claim they support it. And you have Google Cloud Functions, which doesn't support PHP, but supports a lot of languages. Now, there we are, PHP. What do we do? I will be talking mostly about Amazon Lambda here, because this is the most stable provider, the one that you have the most reliable performances and the most widely used. And because I can't run PHP there. So I want to run PHP over Amazon Lambda. I want to run PHP there because I don't know if it's obvious now that I've mentioned PHP and how its execution model fits Amazon Lambda, but PHP is actually perfect for function as a service. It's the same execution model, so we don't have too much effort to do to port PHP applications over function as a service. How do we do that? There's actually one solution which is also explained on, I think, Amazon's blog, and which has been done by many people. It's over GitHub and stuff like that. I use the same technique, so it's nothing new. What you can do is, you see a Lambda is a Linux container, so it's Linux. You can perfectly grab a PHP binary or compile it and put it inside the Lambda and run it using Go or Python or Node or whatever you want. So you can have a Node Lambda. I will use Node because it's the one with the best performances, at least from what I've tried. So you can use a Node Lambda, and inside the Lambda, put the PHP binary, put your PHP script, and run the script from Node. Yes, it works. It's a bit weird, but that's fine, because we are not writing again like a reverse proxy or something like Nginx or PHP FPM. It's really not complicated. There is no load. There are no many requests to think about. This is just one request at a time. So it's like 40 lines of JavaScript. and it's really reliable. Once it works, it just works. Now, it's a bit tedious to have to compile PHP or find the binary and write the JavaScript proxy every time. So this is great. This is why I started the project called Bref. So Bref is an open source project that brings support for PHP on Amazon Lambda. With Bref, you can write lambdas in PHP, just like with any other language. This is a function that takes the event and returns a response. Now, maybe that seems weird to you. PHP is weird, you've got to roll with it. That's just an alias function. It's just for fun, because this is a valid character in PHP. But there's a proper function name in the package. You don't have to use that. That's fine. That's just also for the slides. It's shorter, so that fits in the slides. But I'm happy here that this is great, but I'm not 100% happy. Because I can write lambdas, but I don't want to write lambdas. I want to write what I write every day, Symfony applications and Laravel applications, and then run them on Lambda. So Bref goes further than just PHP support. It has 3 goals. The first one is PHP support, obviously. The second one is deployment. Internally, Bref uses the serverless.com framework. So this is a framework which it's called Serverless, but it's not official at all. It's just a random name. And it's really great for deploying lambdas. So internally, Bref uses it. You don't have to care about the details. You just do Bref deploy, and your application is deployed and in production. This is really great. Bref adds on top of serverless everything related to choosing a PHP version, setting php.ini flags, installing PHP extensions, installing composer dependencies, and stuff like this. So Bref deploy, and that's it. Just one line. And finally, as I said, lambdas they are cool. This is great. And in some cases, you want to write a lambda, but in some cases, you just want to write a PHP application. And you don't want to learn everything from scratch. You may be using Symfony, you may be using Laravel or Slim or whatever. So the third goal of Bref is framework integrations. And I think this is huge. This is a big difference with PHP, and a big advantage is that those applications, they are ready for function as a service. They take very little modification to run on Lambda. And that's a huge advantage here for PHP. How does it work? That's really interesting, actually. It's very simple. Again, PHP is designed to run as stateless. PHP processes, the way they work is there's a request, there's a new PHP process that starts. Symfony or Laravel, we start from scratch, take the request, process it, return a response, and stop. This is the same thing. So I will show you an example of Symfony. This is the index.php of Symfony. We take index.php of Symfony. So this is what happens. We create the Symfony kernel, the application kernel. And that's what usually happens here. So we'll remove that. What Symfony does usually is create a request object, because this is an object-oriented framework. So instead of playing with the global variables and stuff, it creates an object request. The Symfony kernel handles the request, so it will call the controller and stuff. That's where your code runs, returns the response, and sends the response to PHP. That goes away. Instead, we create Bref. We pass the Symfony kernel to Bref, and Bref runs. And Bref will take the event, which represents the HTTP request, and it will turn the event into a Symfony request or a Laravel request. It's just an object. It's simply data mapping here. Then it will call Symfony with the request, and Symfony will run just as usual. This is just a Symfony request. So everything will run in Symfony as usual. Symfony returns the response, and Bref will turn the Symfony response into a response that Amazon understands. So again, it's pretty simple. Nothing really complicated going on here. And in PHP, we have standards too. We have standards for requests and responses, so it makes it even easier to support Symfony, Laravel, and any PSR 15, so the PSR is the standard, PSR 15, those frameworks. Now, I'm sure you've been thinking about performances since I said that PHP is executed by Node. That's all right. The question is there an overhead doing all that? And yes, there is. What I did is I compared a Node Lambda to a PHP Lambda. And both Lambda, just they return hello world. So it should take 0 milliseconds. Oh, yeah, I know what's going on here. Yeah, that's fine. So actually, it's not 0 milliseconds for PHP. Can you read, all right? I can change the, OK. It's 300 milliseconds. So this is really terrible. This isn't fine. Fortunately, we can change the, how powerful the Lambda is by increasing the RAM available. If we do, then the overhead stabilizes around 20 milliseconds. So it will not work for PHP applications that like respond in 5 or 20 or maybe 50 milliseconds. That will not work. That's OK. Don't use Amazon Lambda and Bref for that. But my conclusion is that for something like 80% of all the PHP applications out there, it's viable. It works. Because 20 milliseconds is something you can accept. Remember that you may lose 20 milliseconds, but you may gain operational effort, you may gain huge scalability, and you may actually gain stability in response time. Maybe it has happened to you, but you can write a PHP application with great response time, you put it in production, you're really happy, and then there's a traffic spike. And everything starts to get slow. And instead of 100 milliseconds of response time, you have 1 second. So here, that doesn't happen. It's all stateless. There is no server that gets overloaded. It's just stateless containers. They are just piling up. So you have 20 milliseconds, but it's stable response time. That's really, really interesting. I will squeeze that slide. I can talk to you with all those topics if you're interested afterwards. I just want to not skip the end, which is case studies. I think this is more interesting than those details. So I have 3 case studies of applications running in production with Bref and Amazon Lambda. And I want to share a bit of that experience with you. The first one is called Return True to Win. And it was the application with which I discovered Amazon Lambda. So at the time, I wanted to write a website. This is like a puzzle game for PHP developers. So you have a bit of PHP code here, like weird PHP code, and you have to fill in the blanks to make the function return true. If you succeed, you can move to the next level. It's a game. But I did not want to run code coming from the internet on my server. So I started to look into virtual machines, containers, and stuff like that. It was maybe 1 year ago, 1 year and a half. And yeah, it was complicating setting up virtual machines and containers just for this small website. And it was just, for fun. So I discovered Amazon Lambda, and I thought this is perfect. I will take the code and run it in the Lambda. And even if the Lambda crashes, then that's fine. My website is not affected. So what I did is that I implemented the website using 2 Lambdas. One is actually the website. So it's a really small website, really basic. But this is the website. And when I submit the code, it will call another Lambda, which runs the PHP code that was submitted. I call that second Lambda eval as a service. And I shared it online, and people liked it. So it was great. Remember, I'm not paid for it. This is just for fun. I got quite a bit of traffic on Reddit, on Twitter, and stuff like that, and was really happy. Because I didn't have to handle anything. It was just running. I didn't have to care whether my server was overloaded or response times. It was just working. I didn't have to do anything. And this is for a whole month. So I got that many requests. And during the month, I started worrying about how much I would pay at the end of the month for all of that, because I was happy, but will that cost me a lot? And it cost me only $3. So I was happy. I was happy, and I was also relieved and intrigued, I would say. Intrigued because there's so much potential behind that. It's really interesting to run applications, but it's also cheap. So at the same time, I was working on something called PrettyCI. PrettyCI is a SaaS that basically do continuous integration for coding style for PHP applications. So if you've used PHP Code Sniffer or PHP CS Fixer, that's running those tools in the cloud. So it was a year ago again. The way it ran was that way. You push a commit to GitHub, and GitHub calls my API with a webhook. Now, I know that there's a new commit to process, so I add the commit to a queue, a message queue. I am using Laravel for this. So I was using a job queue like Redis, and I had Laravel workers, or PHP workers, processing the jobs in the queue. So I had five workers, not 4. Anyway, I had 5 workers, and the worker takes the commit, runs PHP Code Sniffer or whatever, and sets the build to red or green. And it worked fine, but what happens if I have like 10 pushes at the same time? They will have to wait in the queue. Or I can add more workers, but then I have to scale up the instance, or I can add another instance, scale horizontally and add new workers, which is fine. But this is I just started this project myself. I don't know how much I will pay for that. Either I keep people waiting, which sucks for them, or I have to pay for scaling, even though I don't have that many users. Then I knew about Amazon Lambda. Great. What I did is that I moved those workers. I actually removed the server, and this became a Lambda. So whenever there's a new message in the message queue, there's a new Lambda that runs immediately. And I can have, again, 1,000 people pushing at the same time. I will have 1,000 runners. So there is no, this is what I get often, there is no waiting queue anymore. This is huge. You go on GitHub, and this is what I see all the time. PrettyCI has finished. It's green or red, I don't care, but it's finished. And Travis and Abwehr, they're still not even running. They are pending, and it makes me mad. I want to code, I want to merge the pull request, and it's pending, waiting for new containers to be free. With this strategy, I don't have to wait. This is awesome. This is amazing for user experience. My builds usually finish in less than 5 seconds. So I push the commit, I try to open the pull request, and it's already red or green before I even open the pull request. So great experience for users. And for me as a developer, this is awesome because I don't have to worry about scaling. It's magic. I can also anticipate costs, which is not something that you can always do with function as a service. But here I know how long my builds take on average. So I know if I have 10 times more users, or if I have 10 times more repositories to watch, I can just multiply how much I pay. I can multiply how much time of processing time I will need by how much it costs, and I will know. The great thing too is that, to be honest, Amazon Lambda is really cheap, at least here, so I don't really pay a lot. I can offer the free service for open source projects, and it costs me 0. So really great for everyone. Okay, and finally, Enoptea. So Enoptea is a French startup, which I think you can guess by the text here. So I don't work with them, but they've been kind enough to share with me some numbers that I can share with you. So this is a startup, a French startup, that basically what they do is they process a lot of energy bills. So they have a lot of PDFs, and they try to extract how much you paid for electricity every month and stuff like that. So it's not really like a huge website, but they have a lot of jobs, of background jobs. And they started doing that using EC2 instances on Amazon and PHP workers, just like me before. And it's great. The startup is growing. They have more and more clients, more and more jobs to process. But they started having like scaling issues, or at least it was taking too much time for them to deal with all the scaling stuff, with new clients and stuff like that. They started also paying a huge Amazon bill. So what they started to do in July here, they started to move the code piece by piece, because it's a lot of microservices. Piece by piece, they moved it from EC2 to Amazon Lambda using Breath. So they haven't finished yet, but what's interesting is that they started paying less and less and less every month. And even in October, it's even less. I think it's over there. They haven't finished again. They expect to maybe divide their invoices by 3 or 4. So I don't have absolute numbers to share with you here, but I have one number for one specific microservice. So EC2, PHP, and stuff. They migrated completely to Amazon Lambda, and they went from $800 per month to $90 per month. And they even got a better service for that, because they used to have servers that were overloaded. They used to lose messages, and they had just, it was a nightmare for us. They were like dev and DevOps. They don't have huge sysadmin skills. So once they moved to Lambda, they actually had no problems anymore. It just ran, and they are really happy with that. So for them, it's great because first they saved some money, so it's great. They increase their margin. For a startup, this is really great. So they pay less and less and less for more for the client. And this is really important for them, they stopped worrying about scaling. They used to be worried when they had to sign a big client. Like, how are we going to run that? We already have so many problems. Now they are not afraid to sign clients and grow, so this is really great for a startup. So anyway, to conclude, what's the takeaway? What should we do here? Should we move everything to serverless and throw away our containers and the Kubernetes stuff and everything? Or should we wait? I think the real question is serverless mature? And the serverless technologies like Amazon S3 obviously, but AWS Lambda, those are mature technologies. They are running in production. They have, you can find many stories online about companies that either migrated to Amazon Lambda or that built their companies on top of that. And you have many success stories. So this stuff runs really great. But the serverless ecosystem, all the tooling, all our experience, our expertise with serverless and functions as a service isn't mature. That's just the truth. We have to talk about this to share information, and even me, I just started playing with that like a year ago. So I'm definitely not an expert here. But that's fine. That's the fact that it's not mature, it's something we can fix. We just have to try, experiment, learn, share, and increase our collective expertise, and our tools to use those technologies. And I think it's worth it. That's why I'm pushing for this. I think it's really interesting, both for developers and even sysadmins and stuff, because it's really easy to use, it's really great, it's a great experience, but for businesses too. You can save money, but the potential about being able to deploy applications really easily and pay very little, having developer teams which are autonomous and able to deploy new applications without having to ask for a new server and stuff. This is really great. So there's a lot of potential here. I think it's worth experimenting at least. Now it's your turn. So the project is on GitHub. If you don't use PHP, you can have a look at serverless.com. You can also have a look at, if you use AWS, you can have a look at SAM, which is like a simpler version of CloudFormation. And if you're interested in what I've shown here, I have more details in articles on my blog here. And if you have any question, I'll be really happy to talk with you about that. Thank you. So we have the Slido system. There it is. Okay. Is it supposed to automatically update, I think?
Is this applicable only for stateless applications?
You mean Bref or something else? Like the Bref project or?
No, all this. All about this.
Okay, this.
If you have to initialize some tool database, then to run queries, something like this, then cost which your application should only start initialization, then serve the request maybe more than exactly time that it works.
You mean for the costs? Or?
Cost to start your application maybe more than serve.
Right. There's something I did not mention here because I tried to make it work in 40 minutes. I did not mention the cold starts. So the cold starts are what you get when the container boots. At this specific time, your container is a bit slower because it has to boot and then your code has to execute. So the first time the container boots, you will take more time to process and you will pay for that time. At least I think so. No, maybe you don't pay for the boot time. That I'm not sure. You don't pay for the boot time. You don't.
If your application needs connections to database,
yeah.
So you have to create connection to database every time when your application starts.
Yes, that depends on the language actually. In PHP, the way it's done here, yes, and that's something I want to look into because you lose the connection every time. But in like Node.js, I think you can start connections and things like that outside of the part of the code that is executed every time. So you can maintain connections. So you only have to wait for the connections to be made only the first time on the cold start. So this is something we can maybe look into details if you want to. It depends on the language you use. And it depends, I guess, also on how you connect to the database and which database it is, and it depends on so many things. Yeah.
You use Java, I think.
So I don't know about Java, I'm sorry. But I think
you use services. You use Java database or Redis or something else as service. You don't have to start with connection tools or something. Just use service. That's all. But how it handle failures of dependent services? I should write my own code for this handle this failures, or it's just it's handled by Amazon.
Do you mean
handling failures of dependent services?
You mean dependent services like database and stuff,
I
or?
write my lambda function.
Yep.
And I ask some service, maybe the base.
Yep.
Where I have to write code that handles these failures.
Yeah. Just like you would.
Outside my lambda.
No, you could. I mean, you can handle the failures just like you would in any application. Like, let's say you want to do a query, maybe the query fails, you have to handle the failure. Now, you can let your Lambda fail, because Amazon will execute your code. So you can have code that fails, and your Lambda will be marked as having an error, finishing on an error. So you can do that. And you can use Amazon to track your errors. But if your code is running and doing many things, and in those many things you have one database query or one API call, you can handle the error yourself. So you can do, for example, use Sentry or cloud services to alert you or anything. So I don't think there's a huge change here. You can do just as usual and catch the errors.
I think maybe Amazon have something like retry, maybe.
Yes.
So do it outside your Lambda function.
Yes, that's something you can do as well. Let's say you have, for workers, this is really great. You can say, retry my Lambda if it fails. But you probably don't want that with HTTP scenarios. So it depends. You can let Amazon retry your Lambda if it fails. But if it's an HTTP request, maybe you want to return a nice error page or a nice JSON response for an API. So again, it depends on what you do. But yes, you can rely on Amazon you can return an error to Amazon. You can.
If you have a couple functions and you need some connection between functions, one function calls another, should I create some other way, like my first function finish work and return other element, and then next function will check this element, or I can just call from one function to another. Should I have some state between two functions? For example, I don't put in a database or in a queue a result of my previous function.
Yeah. So there are a lot of things you can do here. I'm definitely not qualified enough to give you a specific response, and I think it depends on many things. But I can tell you to look into, for example, step functions. So you can have functions that execute one after the other to have a process in several steps. You can, of course, invoke a function in your code. You can think about it differently too. Let's say you have a function that will process something and you want something else to be done afterwards. You can instead push a message in the message queue, which will trigger another function, or you can store like the result on S3 and it will trigger another function. There are so many things you can do. It really depends on what you want to do and the context, I think. Yeah, it opens a lot of possibilities. It's also why it's sometimes a bit complicated to get in the mindset of function as a service. But basically, you can write some small functions and connect them with events, with all you can do on Amazon, like queues, crons, step functions, and there are so many things you can do. And I don't know all of them, definitely. Yeah. Oh, I have a question there. Okay, so this was a Node Lambda and a PHP Lambda with Bref, and the code was actually, it was basically the example I showed in the slides. So it was a Lambda that wasn't doing anything for the performance test. It was just like return hello world. So yeah, I tested hello world. I also tested demo applications of PHP frameworks. I used that to test performances for something called opcache. This is something in PHP, an extension that will, it's like JIT compilation in PHP. It's not really that, but anyway. I tested this application to try and see how it affected PHP performances too. And there was a huge performance difference. So this is great. I don't know if that really answers the question. But in any case, if you want to do PHP, use 1 GB or above. Don't bother with the small ones because it's just too slow. That's too bad, but that's how it is. Do we have another question? Or okay, thank you, and yeah.